Hello, today I'm going to present you my work, a low-cost water management system using the IoT for freshwater fish farms. This is a presentation for IoTx6, of course, at Curtin University via the IDX platform. So, a little introduction of myself. I'm Alexander Johansson from Norway. I'm holding a master degree in IT with specialization in networking from Mahanakorn University of Technology in Thailand. I'm also a Cisco certified network professional in the field of collaborations, including voice, video, instant messaging, collaborating over the IP network. I'm also interested in computer networking. My first LAN setup was between an Amiga 4000 and Amiga 1200 over parallel ports, roughly around 25 years ago, and I love cooking. The idea is quite simple. How can we help the fish farmers to manage their farms efficiently by using IoT technology? Firstly, I got this real problem from a friend in Thailand. The system itself contains multiple sensors to collect data. A low-tech fish farm is easy to set up, but requires a lot of management for keeping the quality of the water at the right level. Another challenge is to save the water resource, which is also needed to be tracked and used wisely in the dry season. The data from sensors will be stored and processed locally in the fog. Open source IoT middleware will also be used for data visualization. Water pump automation will also be programmed. Communication between sensors nodes will be based on IEEE 802.14.5 standard. For the UVP, so what makes our product so unique, you might ask? Our system provides a precision water quality management system using the data from sensors. The system is capable to manage the fish farm with a little user intervention. All information about the water quality along with the information about the water resources available in one place. Our system have focused on the user experience, which means an easy interface for the user by providing a dashboard for mobile desktop devices and instant alert via the instant messaging on alarms and as well. The water quality is a crucial factor for running a fish farm. Without this, you might have a dead fish instead of profit. When looking into problems that we have that we are trying to solve, there are three main problems that we are trying to solve. The water quality, secondly, water resource saving, and lastly, forecasting water resource. Good quality water for fish needs to have a pH value between 7.5 to 8.5, dissolved oxygen value between 3 milligram per liter, ammonia and nitrate less than 0.3 milligram per liter, and oxidation reduction potential or ORP, generally a ORP reading of between plus 125 to minus 200 milliwatt for freshwater systems and ponds. For saving the water resources, our system support having a water treatment pond. So after the water is treated, we can reuse the water. The water is considered treated when they have acceptable reading from the sensors. Farmers need to reserve the water for the dry seasons and need to monitor the level of the water in the pond closely in the rainy seasons for not flooding the fish ponds. For maintaining a good level of water quality, we are using multiple sensors for real-time monitoring so the farmers can act instantly when the quality level of water is decreasing. Automatic water quality correction mechanism will be provided to maintain the water quality by cycling the water. As mentioned before, our system will track the water usage in the farm, and along with the public forecasting data, we can forecast the volume that is needed in the future. So, what parts are needed to solve the problem fish farmers are facing? And an Arduino board with Zigbee wireless module on top of the shield is used to connect to probes and sensors for each pond in the farm. The sensors connected to each sensor node depends on the functionality of the pond. An actuator, a relay actually, is used to switch the water pump on and off. A single board computer is used to install IoT middleware to collect, store, clean, normalize the data from sensor in the cloud. As you may see in this simple network diagram of the system consists of multiple wireless sensor nodes utilizing the IEEE 802.14.5 protocol or Zigbee for connectivity. The coordinator nodes is an Arduino with an Ethernet module, so we can do exchange packets on TCP/IP protocol. Coordinator nodes acts like a gateway to send sensors data from the end device to the server with the MQTT protocol. The server is on a single board computer with Node-RED installed. Node-RED is a programming tool for wiring together hardware devices, APIs, and online services in the new and interesting ways. It provides a browser-based editor that makes it easy to wire together flows using the wide range of nodes in the palette that can be deployed in the real time in the runtime in a single click. When the data is collected, clean it, normalize it, we process in the file. We push the data via VPN tunnel to the cloud. For the business model, we are going to cooperate with the Department of Fisheries of Thailand for grants as one of the channel to introduce our solution to farmers via them. Cost structure includes three parts: hardware, including sensors, actuators, microcontrollers, single board computer, and a cloud infrastructure. Secondly, system design and development, mainly open source software is to be used to keep the price of the product system low. We are going to use model of in-house software development. In-house software development is a good option since we have required technology expertise and professionals available. Lastly, marketing a budget for making the required. Lastly, marketing a budget from marketing is required for reaching the potential customers with the information about our system. Revenue stream including government funding, business investors, sales of sensors, maintenance fee, and support and service contracts. When looking into the market for this product, we are targeting anyone who is interested in running or is already running a freshwater fish farm, with the fish farmers as our primary market and business investors as our secondary market. So, to summarize, our product is an IoT system for low-tech fish farms using open source hardware and software, as and it is a low-cost system to support farmers. Three main features including water quality management, automatic water quality correction, and forecasting water resources. Thank you for your attention.